Hope most of you benefited from the doubt session yesterday, where we discussed all the questions related to the part before dot products from exercise 1 of your module. I will send the recording of that very soon, but the recording in the notes, but you would have got an idea of the level of questions in the module and how to solve those type of questions. Now let's begin today with the new operation in vectors, or the new part of vector algebra, which is something called scalar product. Scalar product, or it is also alternatively called the dot product in vector algebra. So this is a new type of vector operation that we will learn. So first of all, the symbol of this operation, the symbol used for it, every operation in mathematics has a symbol. So likewise in vector algebra is the dot symbol. This is the symbol that is used for it. So if you put a dot in between two vectors, this is read as scalar product of vector A and vector B. This is how we understand it. Okay. Or in short terms, in short language, we just call it vector E dot vector B. So we can just read it as A dot B, but the proper name for this operation is that it is a scalar product. Okay. So definition of this operation. Yes, good afternoon, Prince. Okay, definition of this operation is that it's given by simple mathematical relation that A's dot product with B equals the magnitude of A multiplied by the magnitude of B multiplied by cos of the angle between them, theta. So this is the definition. Yeah, Prince, we just started. So this is the new type of vector operation that we're learning, which is called scalar product. So yeah, you'll understand. It's just, this is the symbol for scalar product or dot product, and this is the definition. So now we are actually starting with the important part, the definition. So here, the definition of dot product is given by, it is equal to the product of magnitude of the vector E. This capital A is magnitude of the vector E, capital B is magnitude of the vector B, and theta is the angle between E and B. Okay. So I'll give you time to note down, but just as an example, for example, if I have a situation where vector E is like this and vector B is like this, and let us say the magnitude of E is 10, the magnitude of B is, let's say, 6, and this angle is 60 degrees, let's say. Then in this case, E dot B will become magnitude of A, that is 10, multiplied by magnitude of B, which is 6, multiplied by cosine of the angle between them. Okay, so that will become, as you can see, 30. Now, if this is in some unit and this is in the same unit, then in terms of unit, this will become unit square. Whatever that unit was, it will become square of that unit because it's product of the two magnitudes. Cos theta is a dimensionless quantity. It does not have any unit. Okay. So we can go back to the beginning, and now you can see that this is the new operation we are learning. The name of the operation is scalar product or dot product, two alternative names for it. The symbol used for the operation is this dot symbol. So anytime you see two vectors with a dot in between them, you read it as scalar product of the vectors A and B, or simply in short form we can say A dot B. Now, what is the meaning of this operation? What is the definition? A dot B kya hota hai? How do we calculate it? So it is magnitude of A multiplied by magnitude of B multiplied by cos of the angle between them. Cos theta, where theta is the angle between A and B. Okay, so just make a note of this part first, then we'll continue on. Okay, Prince, so you understood now? This is where we started, so there's nothing before this. Okay. Alright, so finish writing down this example, all of you. Okay. So now let us understand few more things about dot product. So about the dot product. So first of all, the dot product or scalar product or in say it is applied to two vectors only. Okay, so what we mean to say, for example, is that vector E dot vector B is defined as EB cos theta. Now, this is the definition. Okay. But if I say E dot B, this is meaningless. This operation now will be meaningless. It does not make sense. We cannot calculate this. Why? Because this is a scalar and this is a vector. Okay. So dot product cannot be applied to a scalar and a vector. It has to be operated particularly on two vectors. Now, whatever is on both sides of the dot have to be vectors. So this kind of thing or this kind of thing, this will also be meaningless. It will not make sense. This is meaningless for the same reason. Or for that matter, in vector algebra language, this also does not make sense. This is meaningless. We should use the symbol either this or we can say into this. Then this makes sense. Okay. But this on its own is meaningless. So that's the first point you have to understand, that the dot product can only be operated on or can only be applied on two vector quantities. It cannot be applied on two scalars or on a scalar and a vector, because that's the definition. It depends on the magnitude of the two vectors and it also depends on the angle between them. So if we take a scalar and a vector, it doesn't make sense, no? Because there's no angle between a scalar and a vector. Scalar does not have any direction. Okay, next point to understand. The dot product. Okay, wait. Just give you time to note this down. I'll come back to the point. Finish writing this down, it's fine. Okay. Wait, what you have to? What happened? Okay, now next point. So the dot product of two vectors is a scalar quantity. Okay. That's why it is called scalar product. Because it gives us a scalar quantity. So a very common definition in physics based on dot product. Just a moment, excuse me, like that. Yeah, sorry. So let's understand this. It gives us a scalar quantity. That is why it is in fact called scalar product. So for example, in physics, we have a general definition. The work done by a force, work done W by a force F through a displacement S. It is defined as, actually the definition, the proper definition of work done, which you would not have studied in 9th, 10th because you've not done vector algebra then. Okay. So the definition of it is that work done is the scalar product of force and displacement. Okay. Now you can see in this that the work done becomes F into S into cos theta. So you can see in this equation, the left hand side is work done, which is a scalar quantity. Why it is a scalar quantity? Because this is magnitude of force. So magnitude of a vector is a scalar quantity. No? Similarly, S is magnitude of S. So that is also a scalar. Yeah, and obviously cos theta is just a number. It's not even a physical quantity. It's just a number. So it's a scalar quantity. So it's really a magnitude into a number. So that is nothing but a scalar quantity. Okay. So just as an example, suppose we have a force, okay, of let's say 50 newtons towards east. This force is acting towards east, and it creates a displacement. Is, let's say, whatever, 20 meters towards, okay, northeast. So now we want to calculate the work done by this force through the displacement S. So according to the new definition that we've learned for work done, this is going to be F dot S. So the force is a vector which is of magnitude 20, sorry, whatever that was, 50 newtons, but acting towards east. And the displacement, according to the information given, is a displacement of 20 meters. Is acting in the northwest direction, sorry, the northeast direction. So the displacement of 20 meters is such that this angle should be 45 degrees. So when I substitute here, it should be magnitude of force into magnitude of displacement into cos of angle. So the magnitude of the force will be 50 newtons. That's a scalar quantity. the magnitude of the displacement is 20 meters. That's a scalar quantity, and cos 45 is just a number. So obviously it's a scalar quantity. Just say right. So yeah, one student was not able to log in, whatever. So now you can see the work done here will become 50 into 100, sorry, into 20, that will become 1000 into 1 by root 2, and the unit is Newton meter, or that is the same thing as joules. So it's 500 root 2 Newton meters or joules. But understand now that this quantity that we got on this side, it is a scalar. Okay, so dot product of two vectors gives, or it outputs, a scalar quantity. That is the important thing to do. So this is just to give you an actual example of how we use dot product in physics. The example is about that, but the point really is, the point to understand over here is that the scalar product of two vectors, or the dot product of two vectors, it gives a quantity which is a scalar. So note down this point in this example, please. Okay, so this example is actually showing you the definition, the correct definition of work done. That's in mechanics, which is what we'll come to immediately after finishing vectors. We'll come to the general subject of mechanics in physics. By dot product or scalar product method. Yeah, the values are given in the question. Okay, so this is part of the question, that this is the force both in magnitude and direction. This is the displacement both in magnitude and direction, and what is being asked is the work done. So for that, we'll now use this definition of work done, that it is the dot product of these. We don't need to make the diagram also. From this, we can directly understand that, okay, this is northeast and this is east, so the angle must be 45. So you can directly substitute in the formula. 50 newtons multiplied by 20 meters multiplied by cos of 45. The diagram is just to help you understand, but you can directly apply it in the formula. So if we want to calculate work done by dot product method, we should know all this information. We should know the magnitude of the force and displacement, and we should know the angle between them. Without the three informations, we cannot calculate the work done. Okay, next point, we'll understand about the scalar product operation. Point number 3 is that if theta is 90 degrees, that is E is perpendicular to B, okay, then E dot B becomes 0, because you know by definition cos 90 degrees is 0. On the other hand, see, part of the same thing, if theta is less than 90 degrees, okay, acute angle, okay, then E dot B will be greater than 0, because cos theta is greater than 0 for theta being between 0 and 90 degrees. So acute angle का मतलब ये होता है is greater than equal to 0 but less than 90. But on the other hand, if theta is obtuse, because remember here theta is the angle between two vectors, so it can either be acute or obtuse. Okay. Then automatically the dot product becomes a negative quantity. It's less than 0, because cos theta is negative in the second quadrant, as you know. When theta is greater than 90 but less than equal to 180 degrees. Okay. So depending on the angle, the scalar product of the dot or the dot product of two vectors can be positive, it can be negative, and it can also be 0. But it can be 0 only when we are talking about perpendicular vectors. So that is why you would have heard that common aspect of work done by a force. If the displacement is perpendicular to the force, then the force does not end up doing any work. It does 0 work. Whereas if the displacement is opposite, the angle is 180 degrees, for example, so it does negative work. Or even if it is not opposite, but it's at some obtuse angle, then the work done is negative. Yes, of course. So that is also a special case. That is correct, Dushan. So you can also understand it this way, that if theta is 0, then of course you have the special case. E dot B becomes exactly equal to product of magnitudes, because cos 0 is 1. And similarly, if they are exactly opposite each other, theta is equal to 180 degrees, then in fact E dot B becomes minus of EB, becomes exactly negative of the product, because you know that cos of 180 degrees is negative of unity. So those are also two special cases. Okay, but they are included within this because I have included here. You can see I have included 0 in this and I have included 180 in this. Okay. But yes, you can say that this is the maximum possible value of A dot B. It's equal to AB when theta is 0. And similarly, the minimum value, algebraically speaking, minimum value because negative quantity is minus AB, and that happens when theta is 180. Okay, so quick example. Just work these two out. Now, vector E is given to us like this in the diagram. It is shown to be at 30 degrees and its magnitude is, let us say, 50 units, whatever that unit is. Okay. On the other hand, we have another vector which is shown to us now, which is like this. This vector is just randomly shown over here, where this angle is 30 degrees, and this is a vector of, let us say, 40 units. And we have another vector which is shown to us like this now. This angle is 60 degrees and the magnitude is again 40 units. And you are asked to find E dot B, E dot C, and E dot C. All these three get calculated. Akshat, some calculation mistake you made. No, that is a product of the magnitudes. But angle भी तो देखो ना, A और B के बीच कितना है? Yes, Dushan, that is correct. Akshat, you have to consider the angle between A and B. A and B are not parallel vectors. They are not at zero angle. Okay. So see, the first thing we should do here is that we should understand the angle between the given vectors more carefully. So to understand the angle between the given vectors more carefully, we can do a number of things. For example, we can just produce this line of B forward like this and produce the line of A backwards like this, and we can understand what is the angle between them. So we'll see that this angle between A and B, this angle, ये कितना हो जाएगा? ये 30 plus 30 60 हो जाएगा ना? That's one way to understand it. Similarly, we can produce this one forward and see at what angle it cuts the vector E. So you can see that this angle will become 90 because this angle is 60. but sometimes it's confusing to do this directly. So the more fundamental way of understanding the angles is to redraw the vectors all from common origin. So let's do that. That will give us more clarity ki angles kya hai. So we draw them from common origin. E was already drawn from there, so no problems for E. E was like this at 30 degrees. But remember, B kaisa tha? B was like this, no? B was like this when this angle was 30 degrees. So now when we draw it here, it will come here. You understanding? This vector, we said that this angle is 30. So when we place B over here, how will the vector be looking? It will be looking like this. B will be a vector like this of 40 units, and this angle is 30 degrees. Okay. So it's back to the basic things about vectors, that how do we find the angle between two vectors which are randomly given? It's like this. अच्छा वो C था क्या? नहीं B था. Okay. And C ऐसा था. C was a vector which was like this. This vector was like this where this angle is 60 degrees. So you can see that this angle is 60. So when I redraw C over here properly, how that will be looking? That will be looking like this. Looking like this. This will be the vector C, where this angle will be 60 degrees. And again, I think it's taken, magnitude was taken as 40. Okay. So are the vectors clear to all of you in terms of redrawing them from common origin? It's clear now how you got it. So now you can see that this is 30 and this 60. So this angle is 90 degrees. And this total angle, this is becoming how much? This is becoming 60 degrees. Okay. So now when we want to calculate A dot B, for example, it is AB into cos of the angle between AB. So I'm just labeling that as theta AB. So you can see between the vectors A and B, what is the angle? It's 60 degrees. It's this angle. So ये कितना हो जाएगा? This will be magnitude of A, which is 50, into magnitude of B, which is 40, into cos of which angle? Cos of 60 degrees. So this will become 1000, whatever units they were in, whole square. If they are both in meters, okay, then this is meter square. If they are both in newtons, they are both forces, let's say, so this will be Newton square. So this is your first answer. Many of you got this correct. Okay. Now similarly, when I want to calculate B dot C, for example, मुझे B dot C निकालना है, so that is BC into cos of the angle between B and C. Now you can see what is the angle between B and C. It's this whole angle, ये वाला angle. Now, the angle between B and C that we are calculating, that will be this whole angle, this angle. This will be the theta between B and C. Okay. So that is going to be how much now? That is going to be 90 degrees plus 60 degrees, so 150 degrees. So this will be 90 plus 60 or 150 degrees. So that's what we should substitute. So B's magnitude is 40, C's magnitude is also 40, but the angle between them is 150 degrees. So that will be 40 into 40 into minus root 3 by 2. So कितना हो जाएगा? Minus of 800 root 3 units squared. That will be B dot C. Okay, now the easiest of the three is A dot C, which you can see where, because the angle between them is 90 degrees. Okay, so I'm just minimizing this a little bit so that you can see the whole thing. And it should be quite clear from the question. ओके सो E डॉट C कितना हो जा रहा है, 0 हो जा रहा है. इज देयर इन द डायग्राम ना बेटा. ये थीटा BC देखो क्या है, ये वाले लाइन और ये ग्रीन वाले लाइन और रेड वाले लाइन के बीच एंगल है. सो दिस टोटल एंगल, जस्ट फॉलो माय कर्सर, this total angle here is what it is 90 because that's between A and C plus 60 no, because A and B के बीच 60 है, you know, got it. So just adding the two. Okay, so A dot C कितना हो जाएगा, 0 हो जाएगा. EC cos theta between A and C. Now theta between A and C you can see is this one, no? This angle, this is the theta between A and C, 90 degrees, that one. So that is 0 because it is 90 degrees. Alright, so hope with this example you understood the case where the angle is obtuse or the case where the angle is acute. Okay. Now let's solve an interesting physics problem using this. So what is happening is a ball of mass, let us say 500 grams or half a kg, is projected vertically from the ground at a projection speed of, let us say, 20 meters per second. Take G as 10 meters per second square. Now first thing, find the maximum height to which it climbs. So this is a kinematics question. You know all this from kinematics formula. But now come to the vector part. Now calculate the work done by gravity, that is by the gravitational force on the ball as it climbs or moves vertically from ground to maximum height. So calculate this numeric and show that the work done equals the change in its kinetic energy. So you can see that you can actually solve an interesting application of work energy theorem, that the work done by the force acting on it will equal the change in its kinetic energy by just using this definition. Aman, just check your calculation for the work done part once. Mg will be 5 newtons, not 10 newtons. It's 0.5 kg. No, the force will be 5 newtons. The gravitational force acting on it is 5 newtons downwards. Mg is 5 newtons. Yes, that's correct now, man. Very good. Now you can also show that that value of work done that you got, that is exactly equal to the change in kinetic energy. Now, use the formula half mv square of kinetic energy and use the property that when the particle or when the ball reaches the highest point, उसका velocity momentarily कितना हो जाएगा? 0 हो जाएगा. Whereas initially उसका velocity कितना था? 20 meters per second. So from that you can find the change in kinetic energy, and you will be able to show that the work done exactly equals to the change in kinetic energy. Yes, Dushyant, your answer is correct for maximum height. So I hope you people are preparing properly for the kinematics test coming up on Sunday. So all this I think will be part of that. Yeah, Aman, but the change in kinetic energy will have a negative sign, no? Because final is 0 and initial is positive. So delta क्या होगा? Final minus initial, ना? Dushyant, the work done will be negative. Take direction also into account. Gravity is acting downwards and the vertical displacement is opposite that. No? So the first part, you understand that when you project it from the ground level, yes, that's correct. Prince, it is correct. Aman, you are now correct. So when you project project the ball from the ground at a speed of 20 meters per second vertically upwards at t equal to 0. From kinematics, you know that it reaches a maximum height, and when it reaches that maximum height, momentarily it stops. So this is that maximum height at some time, let's say capital T. So you know these formulae that maximum height is u square by 2g, and that time when it reaches the maximum height is u by g. So anyway, so using this formula, you can see it will reach 20 meters height. This will be 20 meters. Okay. So that is the first thing. The maximum height will be 20 meters. Now the next thing is, see, as it is climbing from here to here, what is the displacement? The displacement of the ball is 20 meters vertically upwards now. Okay. Whereas what about the gravitational force acting on the ball? That is downwards and it's equal to mg. Okay. So second thing now, work done by the gravitational force. So that gravitational force, if I want to write in proper vector form, I should write it as minus mg j cap if I'm taking x and y axis like this. Okay. Whereas the displacement, I should write as positive of h j cap. Okay. So you can see that the angle between them, the force is like this, and the displacement is like this. So the angle between them is 180 degrees. So the work done will become magnitude of F into S into cos theta. Now the magnitude of the force will be mg, the magnitude of displacement is h, but the angle between them is 180 degrees. So in fact, as a body goes up, gravity does negative work on it. So this is going to be minus 100 joules. When you calculate the values given, substitute m as 5 kilograms, g as 10 meters per second square, and the height which we calculated 20 meters. So we'll get this. So this will be the work done. Now we'll also show that that is equal to the change in kinetic energy. because as the ball is going from the lowest position to the highest position, okay, you can also see that the initial kinetic energy will be half mu square. It will depend on the initial speed, and at the highest point, the kinetic energy or the final kinetic energy will be half mv square, where v will be 0. No, 2u by g beta is the total time to go up and come down. मैं यहाँ पे उस ये बात कर रहा हूँ ना कि यहाँ पे कब पहुँचा है when it's reached the highest point. So that is half of the total time. In 2u by g beta it comes all the way down. So this time will in fact be 2 seconds. In 4 seconds it will be back where it started, at the ground again. Okay. This time is from start to maximum height. It's not the total time of flight. Yeah, second part बेटा work done निकाल रहे हैं ना, so F dot S. So force कैसा है, mg magnitude है नीचे की तरफ downwards, whereas what about the displacement? It's vertically upwards ना, so it's at 180 degrees to it, and the magnitude of the displacement is the maximum height, which is 20 meters. So by definition, the work done is the dot product of force and displacement. So that is Fs cos theta. Now what is the F over here? Its magnitude is mg. The F's magnitude, the gravitational force, is mg, which is, you can see, 5 newtons. Whereas the magnitude of the displacement is the maximum height, which is 20 meters. But also the angle between them is 180 degrees because they are opposite. So it is this thing, mgh with a minus sign, because cos 180 is minus 1. Is it clear now, Prince? Okay, now let's talk about the kinetic energy. Now you can see that general formula of kinetic energy is half mv square. Okay. So therefore, initial kinetic energy we can write as that is equal to half mu square. This is at the time of projection. Okay. At projection from ground. So that will come out to be half into 5 kg into 20 meters per second whole square. So that's how much, that is 100 joules. This is your initial kinetic energy. The final kinetic energy, that is at the highest point. We're not calculating final when it comes back to ground, but when it reaches the highest point, that will be how much? 0, because V is equal to 0 at maximum height. Okay. So the final kinetic energy is 0. So therefore, what is the change in kinetic energy? Delta Ke, the change, is the final value of kinetic energy minus the initial value of kinetic energy. So it is minus of 100 joules, and you can see, and therefore the work done by gravity in this case is equaling to the change in kinetic energy, because nothing else is doing work on the body. Okay. Only the gravitational force is acting on it, so it's doing work, but it's doing negative work, and that change is equal to minus 100 joules. So this is doing negative work. That's why the kinetic energy is decreasing. It's decreasing from 100 to 0. Okay, so this is the full proper application of this work done and the relationship with kinetic energy. Of course, now this is not part of this chapter. Okay, the relation between work done and kinetic energy, that will come in a later chapter called work energy theorem. Right now in vectors, we only have to concentrate on calculation of work done. But because this is a type of question you've done in kinematics, you understand it very easily. So I'm just showing you how you can use the vector concept of dot product to show that the work done is equal to change in kinetic energy. Yeah, please. So this was the second question. I mean, the second part of the question, to calculate the work done and then also demonstrate that that work done equals the change in kinetic energy. So that's why we have calculated delta K in the end. Alright. So have the notes, don't worry about writing all the question parts and all that, just make sure you understand the solution. Okay guys, this is clear, I hope. Alright, done now. Now let's come to the next point. We were discussing, I think, point number 3, which was about the angles. Okay, now the next aspect of scalar product, or the next, you can say, property of scalar product. Dot product of a vector with itself just becomes square of its magnitude. This is very obvious because it's basically because E dot E will be magnitude of E into magnitude of E into cos of 0. So that's magnitude of E square. So this is something very, very obvious. And that is why, and specifically what happens is that I cap dot I cap becomes unity. Okay. J cap dot J cap becomes unity. And K cap dot K cap also becomes unity. Whereas I dot J is 0. J dot K is 0. And K cap dot I cap is also 0. Why? Because these are perpendicular. Okay. Same with these two. The unit vectors are perpendicular to each other. So I cap dot J cap will be 0. But I cap dot product with itself will be unity. Why? Because it's 1 into 1 into cos 0. Okay. So this is a very important set of properties. So make sure you understand these and make a note of this. And as far as the standard unit vectors are concerned, unit vector dot product with itself will give you 1. But unit vector dot product with a perpendicular one will give you 0. In fact, for that matter, any unit vector, A cap dot A cap, any arbitrary unit vector dot product with itself will give you unity. Okay, so understood this now? It's very obvious, I think. Okay. Now, next property, very important. E dot B is identical to B dot A. And this is very clear from the definition. So, dot product or scalar product is what we call commutative property. It's a commutative operation, like multiplication or addition. Whereas division, is a non-commutative operation because E by B is not equal to B by E, like that. Now, why this is the case? Because it's very simple. Because E dot B is EB cos theta, B dot A is BA cos theta, but that can also be written as AB cos theta. Whether we write E into B's magnitude into cos theta or B's magnitude into A's into cos theta, numerically is one and the same thing. So that's why it's commutative in nature. Okay. And related to this only the sixth property, that it is also distributive. That is, if we take dot product of A with B plus C, like a normal multiplication in algebra of scalar quantities, we can open this bracket and we can write it as A dot B plus E dot C. So you can remember these two properties together because they are kind of. So this is the distributive property. This is the commutative property. This is the distributive property of the operation. Aman, that will not make sense. Okay, but that will not be this thing, a meaningful operation. What Aman is asking here is that what if I write like this? So this you can see is meaningless because this quantity is now a scalar and this is a vector. So we cannot operate a dot between a scalar and a vector. Okay. However, we can write like this. This makes sense. Okay. This has meaning because this is a scalar and it is just multiplied with a vector quantity. It's not a dot product. So this is a meaningless quantity, but this makes sense. All right, so hope you understood the commutative and distributive property of vector addition of dot product. Okay. Now let's understand with another numerical example why it is commutative, why it is distributive. Commutative तो आपने समझा. The commutative का proof बहुत simple है because it's coming from definition only. The proof that it is commutative you can see over here. That B dot A is BA cos theta, which is the same thing as AB cos theta. So left hand side is equal to right hand side. But how we can prove this property, the distributive property? So let's understand that with a numerical example. Now suppose we are given some vectors like this. So we have a couple of vectors which are drawn like this. So this is the vector E, let us say, and its magnitude is 10 root 3. This is the vector B, and its magnitude is 10. And we have another vector, which is, let's say, the vector C, which is making an angle 60 degrees like this, and its magnitude is something, let's say 25 units. So now demonstrate that C's dot product with E plus B equals to C's dot product with E plus C's dot product. So what we'll do is here we'll show separately that left hand side kitna hai and right hand side kitna hai, and we'll show that they are same. Okay. So now here to solve this question we'll understand left hand side C dot E plus B. Let's calculate how much this is. Okay. Now in the diagram you can see that A is a vector which is like this 10 root 3. B is a vector which is like this 10. So if you draw a vector parallelogram, it's actually a rectangle. So E plus B kaun sa vector hoga? E plus B will be a vector now. It should be like this. Yes. Okay. So its magnitude will become how much? Its magnitude will become 20, and this angle will be 30. Okay. So here E plus B is such that its magnitude is going to be root of A square plus B square, which is 20, because E is perpendicular to B, and E plus B is at theta equal to 30 degrees with respect to x-axis, because this theta will be tan inverse of B by A. In the diagram you can see it as tan inverse of 1 by root 3, so that is 30 degrees. That's the first thing. So now I found out this vector. So next I'll have to take dot product with it, with C, and find out how much that is. So note down up to this point first, please. So what I'm trying to do here is I'm trying to do this question. We want to demonstrate this now. So we have to demonstrate by separately calculating the left hand side with the right hand side. Calculating the left hand side and showing that it is equal to the right hand side. So I'm calculating the left hand side, which is C dot A plus B. So for that I'm first finding out what is A plus B. So A plus B is a vector like this. Next I will calculate the dot product of A plus B with C and find it out numerically how much it is. Okay, so next thing now in the left hand side, let's calculate C dot A plus B. ये कितना होगा? So for that, we can see if I just copy paste from the diagram, that by adding A and B, I've figured out that A plus B कैसा vector है? It's a vector like this one. So A plus B is a vector at 30 degrees to the x-axis. At 30 degrees to the x-axis, and its own magnitude is how much? Its own magnitude is 20. Whereas from the diagram which I had originally given, you can also see that what is the vector C? The vector C is like this. The vector C was something like this. It was of magnitude 25, but this angle was 60 degrees. So now what is the angle between A and, A plus B and C? That angle is this one. This theta is going to be 60 minus 30 or 30 degrees. Okay. So this is going to be magnitude of C multiplied by magnitude of the vector A plus B multiplied by cos of the angle between them. So magnitude of the C is 25, magnitude of A plus B is 20, and this is cos 30. So ये कितना हो जाएगा अभी? It will become 250 root 3. So that is the left hand side of the equation. C dot A plus B has a numerical value of 20 root 3 units square, whatever the unit A, B and C are. Now, just like I've done this calculation, you have to also do the calculation for the right hand side, and finally that will show us that right hand side has the same numerical value of left hand side, and that's how we'll end up demonstrating that the scalar product has the distributive property, that is C dot of A plus B is equal to separately the sum of C dot A and C dot B. Okay, so I've done the difficult part of this, which is the left hand side. Now you note this down and also do the calculation on the right hand side, please. Okay. So right hand side के लिए क्या करो आप? Separately C dot A calculate करो from the diagram given originally, which is on the left side of the screen. So separately you do the dot product of C and A. Separately you do the dot product of C and B, that is C dot B, and add the two and show that that sum should come out to be this quantity, 250 root 3. So just try this out, people. Yes, Prince, you got the answer, no? So just tell me individually कितना आ रहा है C dot A and C dot B. So you can see the right hand side. Yeah, correct. Good. C dot A is 75 root 3. Okay. So we go back to the diagram. You can see that C dot A will become CA cos of the angle between C and A. Now going back to the diagram, you can see the angle between C and A is 60 degrees. So this is 25 into 10 root 3 into cos 60, which is half. So you can see it's 50 root 3. A was 10 root 3, like this. Whereas if you look at C dot B, that is CB, but cos of 30 degrees, because B was like this and C was like this. And this angle was 60, which means that this angle is 30 degrees. Oh, sorry, 120. My mistake. So this is becoming 25 into 10 into root 3 by 2. So this is also becoming 125. Okay. So therefore, RHS, which is C dot A plus C dot B, is just becoming 125 root 3 plus 125 root 3, which is the same thing as 250 root 3. So therefore, you can see that left hand side is equal to right hand side is equal to 250 root 3. So that is giving a sort of way of proving that C dot of the vector sum of A and B is this one and the same thing as C's dot product with A added to C's dot product with hence B, or hence demonstrate. Okay, now people, quite easy. Hope you understood this. Okay, now we come to the last of the properties of vectors which we were noting down, which is very important and which makes use of the distributive property that we are just discussing now. It makes use of this, the last property. That is how to calculate dot product of two vectors given in component form. Scalar product in component notation or component form. So if vector E is given as AX I cap plus AY j cap plus, or let's start with 2D. Let's start an example in 2D, then I'll extend it to 3D. Suppose in this example we are taking 2D component form. Then E dot B can be written as, just replace A in component form. So Ax I cap plus Ay j cap dot product with Bx I cap plus By j cap. Okay. Now you can open this bracket using distributive property. So it's basically we'll be using this kind of property that E plus B dot product with C plus D. So वैसे लिख सकते हैं E dot C plus E dot D plus B dot C plus B dot D. Now we can open this into 4 terms like this. So like that, you just apply this concept over here now to these. So when you apply that over here, this becomes, now remember Ax, Bx, Ay, By, they are just scalars. So Ax into Bx, I cap dot product with I cap. That's the unit vector. Okay. Plus Ax into By, I cap dot j cap. Okay. Then plus Ey into Bx dot product of j with I plus finally the fourth term Ey into By, but dot product of j cap with j cap. Okay. Now when you are solving this next step, just remember that any unit vector dot product with itself is 1. Okay, so I cap dot I cap is 1. J cap dot j cap is 1. But dot product with another unit vector, perpendicular one, is how much? Is 0. Okay. So what will happen here now is that these two terms will become 0. This and this term will be 0. Whereas these two terms, this will be 1, this will be 1. Okay. So ultimately, what is your answer? It becomes Ax into Bx plus Ey into By. This will become our E dot B. Okay. So before you note this down, let's quickly see a numerical example also. So as a numerical example, suppose I have the vector E, which is 2i cap plus j cap. I have a vector B, which is 6i cap plus 8j cap. Okay. And I ask you what is E dot B. So we'll just use the formula. E dot B is Ax into Bx plus Ay into By. So substitute these here. So 2 into 6 plus 1 into 8. So that's 12 plus 8. So that's 20. Okay, so E dot B will be 20 in this case. Okay. One more example I want you to write down, because you have to remember one thing, that when we substitute the components, if there are any algebraic negative sign, that is included. So A is, for example, 2i cap minus j cap, and B is, for example, I cap plus 3j cap. Now I ask you what is A dot B. So again, when you substitute in the formula Ax Bx plus Ay By, don't forget to include the sign. So Ax is 2, Bx, but as far as Ay is concerned, it is minus 1 and By is 3. So this will become 2 minus 3, or this will become minus 1. So in this case, A dot B will come out to be a negative quantity, which you know is always possible, because if two vectors are making an obtuse angle with each other, then their dot product has to be negative. Okay. So this is the formula which we have derived using the distributive property. This is distributive property of dot product. So we have derived this formula using that. And once we've derived the formula, we don't need to write it this way anyway. Every time you're doing a question, you just directly apply this formula. If it's a 2D component, you directly write this formula, Ax Bx plus Ay By. So I'll just leave you to first write down the property itself, then come to the example. So this is extremely important because most of the time we are going to be calculating dot product of vectors given in component form. Okay, written down this and the examples, the examples below. So just make sure you understand the values in both these examples. इसमें minus क्यों आया? Whereas इसमें all the signs are positive. because you can see all the components are positive here, but here this component is -1. E is y component, you can see is -1. Ex is +2, but Ey is -1. Similarly, Bx is +1 and Vy is +3. So whenever we substitute in these formulae, it has to be with the proper algebraic sign. That's also a common mistake that people make in the beginning. डॉट प्रोडक्ट कैन बी नेगेटिव ना बेटा, वो तो देखा ही था हमने, जब एंगल ऑब्ट्यूस होता है तो नेगेटिव होगा ना. So for example, in this case, if you were to geometrically draw these two vectors, you realize that the angle has to be obtuse. Because if you were just to estimate ये vector कैसा दिख रहा है E, the vector E is in which quadrant? It's in fourth quadrant because it has a negative y component and a positive x component. So E is probably something like this over here. And B on the other hand is having a, it's in the first quadrant, okay. But it is also such that you can see B का ये वाला component 3 है, E component 1 है. So B is much more like this actually, because this component is 3 and this is 1. So this angle is definitely more than 45. And here this angle is going to be so this angle will be obtuse. That is what it is showing you, because the dot product is coming out to be negative. You can see that theta has to be obtuse. Whereas in this case, in the first example, if you were to draw the two vectors, you would understand that the angle is acute between them. This is showing you that theta must be acute. Based on this, let's do another example question. Now, this is a very common type of question. Given the vector E is 12y cap plus 16j cap, which of the following is perpendicular to the vector E? Okay, so which one of these four vectors is perpendicular to E? Yes, very good, Aman. That's correct. So remember, is perpendicular to B, then E dot B has to be 0. So just check for each one of these. Just use this concept here to check. So in the first case, E dot B1 कितना हो जा रहा है? It is 12 into minus 3 plus 16 into 4. So you can definitely see this is not 0. So this is not perpendicular. But in the second case, you can see E dot B2 will come out 12 into minus 8 plus 16 into 6. That is in fact 0. Okay, so that means yes, B2 is perpendicular to E. Similarly, you will see that in the third case, E dot B3 is not equal to 0. You do the calculation and you will see. And same for the fourth case. The dot product will not be 0. Now, through this example, you are seeing one very important application of dot product. We can use dot product to check whether two vectors given in component form are perpendicular to each other or not. If they are perpendicular, then their dot product should come out to be 0. So this becomes a very important application for us of dot product. So the easiest way to check whether two vectors given are perpendicular is that their dot product should be 0. Okay, people, hope this example is clear to all of you. Now moving on, dot product in 3 dimensions. So 3-dimensional component. So if A is given as X component plus Y component plus some Z component, and similarly the vector B has also got this time when we do their dot product, you can see that it's the sum of 3 terms, dot product with the sum of 3 terms. So when you open it by distributive property, you will get in all how many terms? 9 terms. But out of those 9 terms, you will also realize that 6 of them will be equal to 0. Because I dot j is 0, I dot k is 0, j dot I is 0, j dot k is 0, k dot I is 0, and k dot j is 0. So when you open this, out of the 9 terms you will get, 6 of them will be 0. So this will be ax bx I cap dot I cap plus ey by I cap dot j cap. So this term becomes 0, this goes away. Plus similarly, sorry, ax by plus ax bz I dot p. So this is 3 of the 9 terms done. I've taken this one with all these 3. Okay. Then the next 2. The next 2 terms will become like this, plus ey bx j dot I plus ey by j dot j plus ey bz j dot j. And then the final 3 terms, ez bx a cap dot I cap plus az dy k cap dot product with j cap, and finally the last of the 9 terms az bz. But the thing is, this expression only looks scary. On its own, it's very simple because you can see that these 3 terms will give you unity. I dot I is equal to j dot g is equal to k cap dot k cap is equal to unity. But the other 3 terms, or rather the other 6 terms, will all give you 0. This term, this term, this term, this term, this term, and this term. They will all be 0 because I caps dot product with j cap or j caps dot product with k cap or k caps dot product with I cap is 0. So those 6 terms are becoming 0. So finally we are left with just the 3 terms where these quantities are unity. So the quantity we are left with finally is how much? It is just the product of the x components plus the product of the y components plus the product of the z components. It's a very easy formula to remember. Ax bx plus ay by plus az. That is x component of the first vector into x component of the second, plus similarly y component into y component plus z component into z. So this is a general form. Actually, you can see the 2-dimensional case is like a special case of this, where az and bz are 0. So we're just left with the first 2 terms. So it's nothing exceptional. It's a subset of this, you can say. Okay, so just make a note of the steps over here. So written this down, people. So let's look at simple example. Correct, Akshat. Okay, so you can see here that E dot B, correct, Prince, that's good, will be given by this simple formula. Okay. So just substitute 2 into 3 plus 1 into 4 plus minus 2 into 1. So 6 plus 4 minus 2, that's 8. Positive of 8. That is our E dot B. Quite simple. Got it now? Okay, now next example. So we are done with dot product. Just we are finding out with some examples. So given E is equal to, let's say, 3 I cap minus j cap plus 2k cap, and B is 4 I cap minus 2j cap plus zk cap. Okay, so find Z if E is perpendicular to P. Very easy question, just try it out. Okay, so let's check. So the solution here will become like this, that A is perpendicular to B implies that A dot B should be 0. So that implies that this formula should be 0. So that implies that 3 into 4 plus minus 1 into minus 2 plus 2 into that unknown quantity Z should be 0. So it gives you a simple linear equation in Z, nothing else. So you get that 12 plus 2 minus. Okay, so Z is this. Okay, people, so hope you understood this question. Now, one final type of question more we'll see. Now, this is like an indirect question. A is suppose I cap plus j cap and B is 2j cap plus 2k cap. Now, we want to find the angle theta between the vectors A and B. Just try this out now. Okay, so ये question हम कैसे करेंगे? We'll use the definition. Use the fact that E dot B is AB cos theta. Okay. Now in this, you can see that what is the magnitude of the vector A? It is root of 1 square plus 1 square, so it is root 2. What is the magnitude of vector B? It is root of 2 square plus 2 square, so that is 2 root 2. Whereas you can also see that what is the dot product? E dot B कितना है? E dot B is 1 into 0 because इसका x component 0 है, plus 1 into 2 plus 0 into 2. So the dot product is 2. So now in this substitute, the left hand side is 2. E dot B is 2. The right hand side is this. Root 2 into 2 root 2 into cos theta. Yes, very good. So theta is 60 degrees. Okay, so you can see that 2 is equal to 4 cos theta. So cos theta is equal to half, which means that theta is equal to 60 degrees. So this type of question also becomes important. Okay. Is it clear, people? Okay, students, so with that, we are done with the dot product concept for today. I mean, we are done with dot product. So next lecture we'll look at some more applications of this, and more importantly, we will see we will see the next type of operation also, which is called the cross product. So meanwhile, you will receive the vector sheet number 6, the worksheet number 6, which will have applications of dot product and examples of dot product. So please try those out in this week, and next week's lecture we will look at more applications, and then we will look at Prince, I will send you the worksheet, okay, because that software is just shut down. I mean, it's got hanged, so it will take me some time. Okay, I'll send you this thing. I'll send you the PDF in just some time, Prince. Okay, that's it for today, people. Thanks for attending.